Hi and Assalamualaikum to all and my beloved lecturer, Puan Nolia binti Sulaiman. My name is Putri Nur Yasmin binti Muhammad Rohizi, PISMP, intake June 2022 from B1. In this video, I would like to present about Task 3 presentation for the course MTES3362 Introduction to Geometry. What is a pop-up card? A pop-up card is a type of greeting card or artistic creation that incorporates three-dimensional elements that pop up when the card is opened. These three-dimensional elements can be anything from simple shapes to intricate designs, creating a visual appealing and interactive experience for the recipient. So, here is an example picture and video of a pop-up card that I took from the YouTube application. We will go through the relationship of pop-up with a pop-up card with the mathematical elements and mathematical procedure.
So here I prepared a video about the process of making pop-up cards.
Next, let's look at the basic techniques used in the production of these pop-up cards. These pop-up cards uses the parallel fold technique. The parallel fold aligns with the original fold, ensuring the angle remains balanced. Therefore, to achieve proper balance in the parallel fold is not the angle but the length that must be equalized. This is expressed as A1 plus B1 equal A2 plus B2. There are two primary types of parallel folds, symmetric and asymmetric. In a symmetric fold, A1 equals A2 and B1 equals B2. A notable example of a symmetric fold is the square fold, where all sides A1, A2, B1, B2 have equal lengths. On the other hand, asymmetric folds encompass all other types of parallel folds. One commonly used asymmetric fold is rectangular fold, where A1 equals B2 and A2 equals B1. The picture on the side shows two main types of parallel folds, symmetric and asymmetric. There are three mathematical elements present in the production of this pop-up card. These include concept of numbers and operations, measurement and geometry concepts, and statistics. in pop-up card production, the concept of numbers and operations play a crucial role in quantifying materials and calculating dimensions. For instance, counting the number of folds and tabs and calculating the dimension of pop-up elements, determining fold lines, or estimating spacing between components may require mathematical calculations. Other than that, measurement and geometry concepts are essential for accurately cutting materials, designing shapes, and determining fold angles. Understanding measurements such as length, width, and height, as well as geometric principles like angles and geometric shapes such as triangles and rectangles, is fundamental in creating visually appealing and functional pop. Next, let's look at the first element of mathematics, which is numbers and operation. In a pop-up card, we can calculate the numbers of shapes and colors used. Firstly, let's talk about the shapes. In the pop-up card, there are 4 shapes used, including 5 squares, 5 rectangular, 7 triangular, and 11 circles. Additionally, there are also 6 colors used in this pop-up card. These include 4 pink colors, 4 purple colors, 10 red colors, 3 blue colors, and 5 green colors. Here is the percentage calculation of the number of colors. In this calculation, I use basic arithmetic operations such as multiplication and division. I also use basic arithmetic operations such as addition to calculate the total dimensions of the pop-up elements and the number of colors. The second mathematical element is measurement and geometry. The concept of measurement is fundamental in producing pop-up cards. Measuring and cutting materials accurately based on the specified dimensions is important for creating well-designed pop-up elements. Therefore, this slide shows the measurement for each element or shape produced. The geometric concept used when designing these pop-up elements includes concepts such as determining angles and geometric shapes. The geometric shapes found in this pop-up are rectangular and squares. Next, let's look at the statistics for this pop-up card. Referring to the mathematical elements mentioned earlier, which are calculations on numbers and operations, and measurements and geometry, we can make 3 statistics. The first statistic is based on the usage of elements found in the pop-up card. This statistic is shown in the form of a tally table or frequency table. Here we can conclude from the table that there are 4 shapes used, which are 5 squares, 5 rectangulars, 7 triangulars, and 11 circles. The second statistic is also in the same form, which is in the form of tally table and a frequency table. This table shows the heights of each shape. There are 3 height measurements that can be identified when referring to the mathematical elements mentioned earlier, measurements and geometry. From this table, it can be concluded that there are 3 shapes with a height of 1 cm, 6 shapes with a height of 3 cm, and 1 shape with a height of 6 cm. The last statistics are in the form of a pie chart. This pie chart shows the usage of colors found in the pop-up card. Before we convert the percentage data into a pie chart format, we need to calculate the angles using mathematical elements, which is numbers and operation. This picture shows the calculation path for each angle for colors usage. After that, only then we can produce the correct pie chart according to the data collected. Therefore, through this pie chart, it can be concluded that the color red is used the most, taking up 138.6 degrees, and blue is the least used color, taking up an angle of 41.4 degrees. This is the references that I used to create this presentation slide. So that's all from me. Thank you. Bye.